Now we're going to use our electron dot symbols to draw Lewis structures. And you should have learned to draw Lewis structures in general chemistry, where you basically counted up all the electrons and divided it by 2 to figure out the number of pairs, and you placed them around the atoms to make a valid structure. And you can certainly do it that way, but I'm going to show you a way that I think is a little bit easier. And we'll keep in mind what a Lewis structure is. So a Lewis structure shows all of the atoms, it shows the bonding arrangement, and all of the lone pairs. There's a few key guidelines. We're going to draw only valence electrons. Hydrogen can only have 2 electrons, a duet, and second row elements can have no more than 8 electrons. Now, once you get down into the third row and lower, those can have expanded octets. But we typically don't work with many of those in organic chemistry. So let's do some examples. We'll follow these general guidelines and figure out how to put some structures together. Another thing to make sure you keep in mind as you're figuring out where to put atoms, things that only form one bond, like hydrogen or a halogen, and halogens we often abbreviate as just X to be generic. Because those can only form one bond, put those on the terminus of your molecule. And then things that can form multiple bonds, things like carbon, nitrogen, and oxygen, put those in the middle. And that will help you arrange your atoms. Okay, so we're going to go through some examples. Let's start really simple with water. And again, you probably learned how to do water in general chemistry for the Lewis structure by counting all the electrons, but we're going to do it through the Lewis dot structures. So we want oxygen in the middle because it can form multiple bonds. And let's draw in 6 electrons. And then the hydrogens will go on the ends where they can form one bond. Okay, so basically you're back to nursery school where you were connecting the dots. That's all we're really doing here, is find unpaired electrons, connect the dots to form bonds. Now you can clean it up if you want. Make sure, since it is a Lewis structure, we keep those lone pairs on the oxygen. And now, once you've drawn the structure, we can see that the oxygen does in fact have an octet. 2 electrons in this bond, 2 in this bond, 2 here, 2 here. And the hydrogens have duets. They each have 2 electrons sharing with the oxygen. Let's do another example, C2H6O. And I'll go ahead and tell you there's often more than one correct way to connect these, and that's okay. And we're going to look at a couple of options with this one here. And as molecules become larger, you increase the number of possible structures. So for this one, I'm going to start with the carbons, and we have 2 carbons. So let's just throw those on here and draw the electron dot symbol for carbon. And then we also have an oxygen, so let's just put it right here. There's oxygen, 6 electrons. And before you can put in the hydrogens, sometimes it's useful to go ahead and connect some of the dots. So we can connect here and here. Now let's distribute the hydrogen around the remaining unpaired electrons. We have 6 hydrogen to distribute. So we'll go 1, 2, 3, 4, 5, and 6. We'll connect the dots. And we're done. Now, if you want to make it look a little nicer so you don't see all the unpaired electrons in your drawing, you can clean it up. And one thing that people sometimes do is just make that an OH, and that's okay. Technically, if it's a Lewis structure, we do draw out all of the bonds. So for now, we'll go ahead and draw that bond out completely. Now, what if you did this a little bit differently? So what if you started this and you decided to put the oxygen in between the carbons? So if you had done that, you still could have connected all of the dots in a completely valid fashion. And you get this structure. That's perfectly fine too. So what this is, it's an isomer of the first molecule. These two are considered isomers. And there's different types of isomers we're going to explore as we progress through the semester. But for now, the most general definition of isomers, they're different molecules with the same molecular formula. And that's what we have here. Both have the molecular formula C2H6O, but these are different molecules. They have different properties, different boiling points, different toxicities. So the first one up at the top here, this is known as ethanol. And ethanol is something that you can consume in moderation without any serious toxicity. But its isomer, which is dimethyl ether, this is not something you would want to consume. Now we're going to look at ethene and draw the Lewis structure of it, C2H4. So if you go about this one and we start with the carbons, we'll put the 4 electrons around the carbon. And here we can go ahead and join the 2 carbons together. But now notice each carbon has 3 unpaired electrons, but we only have 4 hydrogen to work with. If you run into this kind of situation, a good place to start is to just arrange the hydrogen as symmetrically as possible. So I'll put 2 on this carbon and 2 on this carbon. Now we'll connect those dots. So now we're out of atoms to add, but what we can do from here, since each carbon has an unpaired electron, let's just connect those together to make a double bond. So now if we clean this structure up, we have a carbon-carbon double bond. Each carbon has 2 hydrogen. And this is completely valid. Every hydrogen has 2 electrons. Every carbon has 8. So if we look at this carbon here, there's 2 electrons, there's 2 in the first and 2 in the second bond. So an octet around that carbon.